Here we are in section 7-2, exercises 22 through 30. And remember, we're going to have two major rules that we're going to be following in simplifying each expression. The first is that when you have the square root of a times the square root of b, that equals the square root of a times b. That's the first rule that we're going to use. The second one is that when you have something like 5 square roots of a plus 2 square roots of a, these act just like common like terms. And so we get 7 square roots of a, just like we did with x's and y's and z's and all that with like terms. And you notice when 28 through 30 come around, we've got binomials that are multiplying together. All the rules that we've used previously will combine with the simplification we've been doing with radicals to be able to handle these kind of numbers. So it's going to go ahead and do it. Number 22, this is 2 square roots of 5 plus 7 square roots of 5. Well, that's 9 square roots of 5. They're like terms, and so we combine like terms. Just like 2x plus 7x would be 9x. 2 square roots of 5 plus 7 square roots of 5 is indeed 9 square roots of 5. All right, number 23, square root of 45 minus 4 square roots of 20. These are not like terms, so we simplify them first. This is, let me see, square root of 5 times 5 times 3. Nope, just kidding. 5 times 3 times 3. There we go. So this is 3 square roots of 5. And this over here is 2 times 2 times 5. There's a perfect square. Comes out minus 8 square roots of 5. Yeah, so this square root of 4 came out here and made that, it was a 2, so it made that an 8. 3 square roots of 5 minus 8 square roots of 5s, they are now like terms. So we get negative 5 square roots of 5. Good. Number 24. Square root of 18, this is 3 times 3 times 2. Square root of 3 times 3 is 3 square roots of 2. Good. Plus, this is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. So that comes out, and that comes out. There we go. So 3 times 2 times 2 is 12. And that guy stays in there. So now we have 3 square roots of 2 plus 12 square roots of 2 gives us 15 square roots of 2. Is that right? Yeah. So really, and we're talking about, hey, we have 3 of those square roots of 2, and that other square root of 2, we got 12 of those square roots of 2, and so that's kind of why we say it 15 square roots of 2. It's a plural. We got 15 of those buggers running around. All right, number 25. 360. I don't know what that breaks down into. So that's going to be 2 times 180, which is 2 times 90, which is 2 times 45, which is 5 times 9, which is 3 times 3. Okay, so we get 2 times 3. Okay, so that's just 6 square roots of 10. Oh, that wasn't so bad. Oh, yeah, that's 36 times 10. Square root of 36 is 6. Plus, square root of 40 is 2 times 20, which is 2 times 10, which is 2 times 5. So that's 2 square roots of 10. That guy comes out, but those guys both stay in. Oh, 6 square roots of 10 plus 2 square roots of 10, 8 square roots of 10. All right, number 26. This is 2 times 14, which is 2 times 7, which means that set comes out. Square root of 2 times 2, that's 2 square roots of 7, plus 2, let me see, this is 7 times 9, which is 3 times 3. That set comes out. 2 times square root of 9 is 3, which gives us 2 times 3 is 6 square roots of 7. 2 square roots of 7 plus 6 square roots of 7 is 8 square roots of 7. Excellent. All right, number 27. We have square root of 44. That's 2 times 22, which is 2 times 11. So square root of 4 is 2 square roots of 11. So that set comes out of the square root. 2 square roots of 11 plus, this is 2 times 12, which is 2 times 6, which is 2 times 3. And if we do that, this comes out as a 2. 7 times 2 is 14, and we're left with square root of 6. Those are not like terms. 2 square roots of 11 and 14 square roots of 6, but they're as simplified as they can be, so we can't combine them. We're stuck right there. All right, number 28. Okay. Ooh, this is a binomial, so we have to remember to distribute each set. So we get 10 minus 14 square roots of 3. And again, these get treated just like an x or a y. And then we jump this in and we get plus 15 square roots of 5. And minus 3 times 7 is 21. Square root of 5 times square root of 3 is square root of 15. And that just has a 3 and a 5, so it can't simplify. Square root of 5, square root of 3 there, as simple as they can get. That's kind of a 4-term polynomial there that cannot simplify anymore. All right, good. Number 29. Okay, so 3 times 4, that gives us 12 minus 9 square roots of 2 plus 12 square roots of 10 minus 9 square roots of 20. Oh, can any of these simplify down? Square root of 2, no. This is 2 times 5, so we don't get a perfect square there. This is 2 times 2 times 5. So square root of, there we go. That'll come out and make it 12 minus 9 square roots of 2 plus 12 square roots of 10 minus 18 square roots of 5. Is that as simple as we can get it? Yes. And this square root of 10, that's the square root of 2 times square root of 5, so it doesn't simplify down, so we do not have like terms in order to make that nicer. All right, and the last one, number 30. 7 times 7, 49, plus 14 square roots of 5, minus 14 square roots of 5, and then minus 4 square roots of 25. Oh, these are like terms, and they completely cancel each other out. And we get 49 minus 4 times square root of 25. That's actually 5. So this is minus 20. We get the answer 29. Fascinating. Some of you may recognize this as a difference of squares has happened here. And yeah, this special conjugate relationship, that's what allows these middle terms to cancel and gets us completely out of the irrational world. It allowed this last term, 2 square roots of 5, to square, the 2 times 2 and the square root of 5 times the square root of 5, and the 7. So we got completely to a rational number. No irrational component on that one. Good.